Did you know that the basic cause of cancer was discovered back in 1923? And the scientist who made this discovery was awarded the Nobel Prize in Medicine for it in 1931. But here's the thing. Only a tiny number of people actually know about this discovery because, unfortunately, this truth has been hidden from the public. In 1931, a German scientist named Otto Heinrich Warburg, who lived from 1883 to 1970, received the Nobel Prize for his discovery of the basic cause of cancer. Dr. Warburg found out that cancer is the result of an anti-physiological lifestyle. So what does that mean? Well, an anti-physiological way of eating, basically, consuming mostly unhealthy foods that acidify the human body, and being physically inactive, creates an acidic environment in the body that's low on oxygen. When cells become acidic, they push out oxygen. And when there's not enough oxygen in the cells, an acidic environment is created. Dr. Warburg explained it like this. The lack of oxygen and acidity are two sides of the same coin. If you have one, you have the other. So, if you have too much acidity in your body, you're automatically going to have a lack of oxygen. And if you don't have enough oxygen, your body becomes acidified. An acidic environment is simply one without oxygen. He even said, if you take away 35% of a healthy cell's oxygen, you can turn it into a cancer cell in just 2 days. He went on to say, all normal cells absolutely need oxygen, but cancer cells can live without it. This is a rule without exception. Now, let's talk about the tissues in tumors. They're acidic, but healthy tissues are alkaline. In his work, The Metabolism of Tumors, Dr. Warburg showed that all cancerous forms meet two key conditions, blood acidity and hypoxia, which is a lack of oxygen. He found that cancer cells are anaerobic, meaning they don't breathe oxygen. They can't survive when there's a lot of oxygen around. Cancer cells can only survive with glucose and in an environment without oxygen. This means that cancer is essentially a defense mechanism that our cells use to survive in an acidic, oxygen-poor environment. On the other hand, healthy cells thrive in an alkaline environment full of oxygen, which allows them to function properly. But cancer cells, well, they survive in an acidic, oxygen-deprived environment. Now, here's the important part. The acidity and alkalinity of our bodies depend on the food we eat. Once food is digested, it creates either an acidic or alkaline environment in the body, depending on its nutritional profile. To put it simply, the alkalinity of your body is determined by what you eat. Acidity or alkalinity is measured on the pH scale, which ranges from 0 to 14. 7 is neutral. Anything from 0 to 7 is acidic, and anything from 7 to 14 is alkaline. For our cells to work properly, they need a slightly alkaline pH, just above 7. For a healthy person, the pH of their blood is between 7.40 and 7.45. Your body is constantly working to self-regulate its pH, so it doesn't slip into metabolic acidity. But some foods can acidify the blood and pollute the body. Now, let's talk about foods that acidify the body. Refined sugar and all its derivatives are among the worst because they contain no proteins, fats, vitamins, or minerals, just refined carbs that harm the pancreas. Its pH is 2.1, which is very acidic. Then, there's meat, every type of meat, as well as animal products like milk, cheese, cream, yogurt, eggs, and so on. Refined salt, refined flour, and all its products, like pasta, cakes, cookies, etc., also acidify the body. Plus, bread, margarine, caffeine, alcohol, tobacco, and all industrially processed and canned foods, which are loaded with preservatives, artificial colors, flavors, and stabilizers, all contribute to acidity. And don't forget synthetic antibiotics and most pharmaceutical drugs. They also worsen acidity. But what about foods and habits that actually help alkalize the body? Raw vegetables. Yes, even though some might taste acidic, they actually become alkaline once inside your body. Raw fruit is another one. Take lemons, for example. They taste super sour, but inside your body, they actually have a very high alkalinity. And almonds are really alkaline too. Whole grains can be helpful, but only millet is a truly alkalizing grain. Other grains are slightly acidic, but an ideal diet should include about 20% acidic foods. Honey is also great because it's highly alkaline, and so is chlorophyll, found in green plants, which are incredibly alkaline. Water is another key factor. Staying hydrated is essential because water helps produce oxygen. So drink water throughout the day in small sips. Exercise is crucial for maintaining the body's alkalinity because it brings oxygen to every part of your body. A sedentary lifestyle? That's not the way to go. It can destroy your health. Now, here's something important to note. Chemotherapy actually increases the acidity in the body. It acidifies the body to such an extent that the body has to tap into its alkaline reserves to neutralize that acidity. Unfortunately, that means the body sacrifices minerals like calcium, magnesium, and potassium from places like your bones, teeth, and hair. That's why you might notice changes, like hair loss, in people going through chemotherapy. Other medications can also increase acidity, so it's best to avoid them whenever possible. Here's the key takeaway. Cancer can't develop in a person who eats healthy, drinks plenty of clean water, and stays active. If you want to eat right, aim for an 80% alkaline diet and avoid foods that are mostly acidic, like sodas, sweets, fast food, meat, milk, eggs, snacks, and so on. Try not to overuse salt. Keep it to half a gram of unrefined salt per day, max. And if you're dealing with cancer, alkalizing your body as much as possible is crucial. You can do this by drinking fresh fruit and vegetable juices, cutting out all toxins, doing hot-cold showering, staying physically active, and taking herbal tinctures. All of this will help reduce the acidity in your body and bring it into the alkaline zone, a pH over 7.0, where cancer cells can't survive.